even if the data support your expected result, you're not done. There's still a couple more steps. And so, just to go back, we have phase 1, like one of our phases. Phase 2, and we're just going to consider this next part, phase 3. And now we have our discovery. I'm going to actually write discovery and collaboration, since you'll find out with this mini project that science cannot be done alone. And with this phase, we get supported results. We may see some benefits of the conclusions we make. And by sharing our data and our analysis, we can get community analysis, so analysis by other scientists and their feedback. So maybe this would involve publication of your results. But you don't just have to publish it. You can also see if others can replicate your results. Because your results aren't really worthwhile or reliable if they can't be replicated. You can get people to review it, to review your data, and get their feedback. And all of this feedback, may lead to some new questions that you may have. So now we're back at phase 1, but with a little bit more knowledge behind us when we get there. Conclusions that we can make in science based off our discoveries can also have very significant benefits. We can develop technology, new technologies based on the data that was collected and the results and analysis of that data. We'll talk about this more in our next unit, the testing of ideas, and sharing that discovery with others can also lead to our ability to address societal issues. It can inform our policies that we make. But a really big benefit we want to talk about is that you are building knowledge. And this is not just for yourself. Like, obviously you're building your own knowledge, but you're also building the community library of science knowledge. So this is very, very important. Building knowledge is a purpose of science. And maybe this new knowledge may lead to new questions. So you see, this is a little bit more of a mixed up picture. It's not as easy to explain as having the 7 steps of a scientific method that we talked about up here. You have to have a period of exploration where you review the literature, you get data and results from other people, you make observations by yourself, and you collaborate and ask questions. And then you're able to move on to design your own investigation or experiment and collect data. And it's not as simple as collecting data and analyzing it. Sometimes your expected result and your actual results may completely be different, in which case you'll need to develop your hypothesis and try again. Occasionally, the data that we interpret supports the expected results. So the actual results equal the expected results. In that case, you've made a very important discovery, in which case it's time for you to collaborate with outside scientists. This can be if you publish your results and they can replicate it, Or if you just send your results and say, hey, what do you think about this? Can you see any issues or any holes or gaps in my experiment that I might have to fix? And then, of course, whenever you make a scientific discovery, like developing technology, addressing societal issues, informing our policies, but I think one critical one that we can't forget about is that a huge benefit is that it contributes scientific knowledge and builds scientific knowledge. And this is not just for you. You're building knowledge for the entire community of science. So it's more than just you. You're contributing to discoveries that others have made. And yes, both of these together, or independently, can lead you to new questions that you may be asking, which will lead to new experimentation to find data, and would lead to even more conclusions, which would lead to even more knowledge. So you see how this is a little bit more of a cycle than it is a step-by-step process.